Now, Rutherford, he had developed a model of the atom in which the nucleus was where all of the positive charge lived within the atom. He had proved this using the gold foil experiment. Knowing that all the positive charge was in the center, it was hypothesized that electrons would orbit around that positively charged nucleus because of their attraction to it, much like planets would around the sun. Now this model, however, couldn't explain chemical reactions, how or why they occurred, or some physical properties like the glowing of red-hot iron, for example. But in about 1850, I guess there was a study of the light that was given off by a hydrogen lamp. And by some calculations about the types of light that come out of it, Bohr was able to surmise, I guess, kind of the following. That, yes, the nucleus was in the center, and electrons did orbit around the nucleus, but also that they had spherical orbits around that nucleus, and that each of those orbits had a certain energy. That the electrons close to the nucleus, they were low in energy, and in the next principal energy level, they would be a little bit higher, and then in the next orbit, or principal energy level 3, they would be even higher in energy, and on and on and on and on. So the closer an electron was in orbit to the nucleus, the lower energy it had, and the further it was from the nucleus, the higher energy it had, almost just like it's high up, away from the nucleus. Now, these orbits, they were called principal energy levels. They are represented by the letter n. So the first orbit is n is equal to 1, the second orbit is n is equal to 2, etc., etc. Now, it was said that these orbits have very specific amounts of energy. Energy is quantized. It can only be in very discrete amounts. And also that electrons could travel between these different energy levels, between these different orbits, by either accepting energy, perhaps in the form of light, or by releasing energy, perhaps in the form of light. So, for example, if light hits a hydrogen atom, so light is represented here by the wavy white line. If light hit the atom, perhaps an electron might absorb that energy, and so it might go from a low energy level to a high energy level, n is equal to 1 to 4. And also, that electron being up high in energy now might have a tendency to fall in energy to a more stable position, and when it falls, it decreases energy, it releases that energy as light. And in fact, this proposal was an exact description of the light that had been released in very specific energies by hydrogen lamps, which had been shown around 1850. So this model is quite accurate in that it shows that, yes, there are energy levels for electrons, and electrons can travel between those energy levels by absorbing and releasing light. It does show very specific energy levels, and in fact, on all elements, there are very specific energy levels. However, this model is very simple. It's only showing certain energy levels, and there are only this small number of energy levels for the simplest of all elements. This only works for hydrogen. And I guess just one more thing, this amount of energy which is absorbed or released, this is called a quantum of energy. A very specific amount of energy which can be absorbed or released. Energy is quantized around the nucleus. Okay, so this model is great for hydrogen, but doesn't work for other elements. However, further study provided a quantum mechanical model, which does work for all elements. And it shows that instead of there being just these general energy levels of 1, 2, 3, 4. There are sub-levels of energy, so that instead of just being n is equal to 3, there are these sub-levels, 3s, 3p, 3d. Now these sub-levels will also be called sub-shells. Now these sub-shells, they have orbitals within them, and these orbitals, you can see them drawn here, these are regions in which electrons spend greater than 90% of their time. You've got the nucleus, and you've got electrons, perhaps in a 1s subshell, or orbital as well. They're not actually flowing in a certain pathway, but instead they're wandering randomly all throughout this region, in this three-dimensional region. Sometimes they're deep within it, sometimes they wander out of it, but they spend about 90% of the time within this drawn-out volume. One type of subshell is the s subshell, and the s subshell has s orbitals. They are spherical in shape. Now, the p subshells, they have p orbitals. They are dumbbell in shape. The d subshell has d orbitals. They have clover leaves. And then finally, the f subshell has f orbitals, and they are just wackily shaped. I'm not going to draw all of them. All right. Thanks for watching, guys.